Welcome back to our Lesson 21 homework review, Part 2, Tangents and Secants in a Circle. Our second question, in the diagram below, secants PT and PU have been drawn from exterior point P such that the four arcs intercepted have the following ratio of measurements. The measure of RS, arc RS, to the measure of arc ST, to the measure of arc TU, to the measure of arc UR, equals 1 to 4 to 4 to 3. Our first question is going to be, if the measure arc RS is going to equal to x, then write an equation to use to solve for x and then find that value. Well, so let's take a look. All right, so if the measure of RS is x, and that's 1, all right, that would mean the measure RS, measure of ST, would be 4x because it's 1 to 4. And the same thing for measure of arc TU would be 4x, and the measure of arc UR would be 3x. So our equation would be adding up all the four arc measurements, in this case in terms of x, which is 1x plus 4x plus 4x plus 3x, and we're going to get the full circle measurement of 360 degrees. Well, adding 1 plus 4 plus 4 plus 3 will give us 12x equals 360, and divide both sides by 12, we get x is equal to 30 degrees. So this is the equation we use by taking, again, a lot of times ratio problems, when they give you ratios, there's a lot of times we're going to add up those numbers because we'll get the sum in this case, or some kind of way to combine them together. And so here we just know that all the four arcs add up to 360. So now we're going to find the value of each one. So here, the measure RS is going to be 30 degrees. Okay, and the measure of ST was 4 times 30. 4 times 30 is 120 degrees. And the measure TU is the same way, 4 times 30 is also 120 degrees. And the measure UR is going to be 3 times 30, or 90 degrees. So I'm going to label those on my diagram, hopefully help out a little bit, because for other parts of the question. So here's 120, 120, and here's 90. All right, so now the last part of the question is going to be part P. Well, not the last part. Part C, it says find the measure of angle P. Well, okay, so the angle P, to do this, we need to take a look at the relationship when two secants intersect a circle. And so here, our rule is a secant line is a line that intersects a circle at 2 points on the circle. So that's what secant line is. A tangent line only hits the circle at 1 point. We talked about a chopstick in the sense of where you pick up meatballs with chopstick at the points where the chopstick picks up the meatball, that's where point of tangency. Well, when you're first learning to use chopsticks, at least my parents were, they would find it funny to, have me try to pick up a meatball, and it's very difficult, when you're first learning. So you would stab the meatball with a chopstick, and that's how what a secant line is doing. It goes through the circle at 2 points. So that's what it is. So instead of touching the circle at 1 point only, secant goes through a circle at 2 points. So the measure of an angle formed by two secant line circle is equal to 1/2 the measure of the difference of the intercepted arcs. Okay, so let's go over this one. Okay, so we'll have the same diagram. So we have circle O, secants P and U. I'll put the little hats on there. So I've got to put hats on there. 1 hat and 2 hats. Okay, and they meet externally at P. Now the extra thing is RT is drawn. So I'm going to again draw a line segment RT. And of course, 2 points you can use to construct any line segment. So, okay, so I'm gonna bring this down a little bit here. Okay, maybe not. So first thing we do is, oops, sorry about that. Here we go. So I'll go over step by step. The first step in this situation is that we're gonna say that the measure of angle URT, okay, is equal to 1/2 the measure of UT. So measure angle URT, so this angle here, angle URT, is equal to here, 1/2 the measure of arc UT. That should be arc UT, not line segment UT. So let me just make a little adjustment to this. It should be arc UT. Okay, and so then the measure angle RST, so I'm going to put that blue, or why not? Oh, it's not sure it's black. Okay, fine. So RTS is 1/2 the measure of arc RS. And the reason is a measure of the squared angle is equal to 1/2 the measure of the intercepted arc. So we see in this case for the red angle, it traps the arc UT in its mouth, and the black angle, it traps arc RS in its mouth. Okay, so then we take a look at the next part where we see the measure of angle URT, is equal to measure of angle P and measure angle P plus the measure angle RTS. So here, those two angles add together measurements is equal to the measurement of angle URT. Or if we move things around, the measure angle P equals the measure angle URT minus measure angle RTS. Our reasoning for this is the measure of an inscribed angle of a triangle is equal to the sum of the two remote interior angles. This has to do with the exterior angle of a triangle. And you may say, what triangle are we looking at? Well, here's triangle PTR. And our exterior angle would be angle URT. So if we know that relationship is true, then we also can say in this case that here we can replace the measure angle URT with the 1/2 the measure of arc UT, and replace the measure of angle RTS with 1/2 the measure of arc RS, and we're going to get, in this case, the measure angle P equals 1/2 the measure of arc UT minus 1/2 the measure RS, or 1/2 the difference of arc UT minus arc RS. And here is substitution. The quantity may be substituted for is equal in the expression, but what it comes down to is this, okay? So here, angle P intercepts two arcs, arc UT and arc RS. And the angle measure is equal to 1/2 their difference. So we see that's the case here. So in this case, we'll put the whole page up here so you can see everything together. Secant line is a line, is a circle, a 2-point circle. The measured angle formed by two secant lines of circle is equal to 1/2 the measure of the difference of the intercepted arcs. So 1/2 the measure difference of intercepted arcs. Okay, so let's take that rule and let's go back to our question here, question number 2, and we're going to see the measure angle P. So we're going to say in this case, the measure angle P is equal to 1/2 the measure, the difference of the measure of arc UT minus the measure of arc, I believe is RS, arc RS. Just to make sure, yep, UT and RS. Very similar to our problem from before. Here's the angle P. Okay, just like we did in this sort of informal proof. And so now you have numbers though. So with numbers, we can do is we can plug them in. So the measure of angle P equals 1/2, well, the measure UT is 120 minus, in this case, 30. Well, 1/2 of 90 equals 45 degrees. Okay. Now the last question for question number 2, well, that would be in this case if we connected line segments UT. So let's connect line segment UT. Okay, I'm gonna make this a full page. And so here, moves up a little bit. So we connect line segment UT, and it says, what would the measure of angle UTS be? Well, the measure of angle UTS is equal to 1/2 the measure of the arc intercepted, which would be this giant arc here. Measure of arc URS. Now, 3x plus 1x is 4x. We know it's 120 degrees. So 1/2 of 90 plus 30 Half of 120 is 60 degrees. Okay, so there goes our question number 2. All right, let's continue with question number 3. Here it says in circle A shown secant DE and tangent DG are drawn. It is known that the measure angle BAC is equal to 72 degrees, which would mean in this case the measure arc BC is equal to also 72 degrees. Because the measure of central angle is equal to the measure of the arc intercepted. That's 72 degrees. Now for the measure of arc EBC. Well, EBC would just be this whole thing here. So that would be the measure of arc EB plus the measure arc BC, which is 96 plus 72. That's equal to 168 degrees. Now for the measure arc EFC. Well, that's the rest of the circle. So we would do 360 minus that 168 degrees. But that would be, in this case, 360 minus 168. Let's see. That would be, it's 2, and then a 9, 292, I think. 192, sorry, 192. 192. Shucks, almost made a bad arithmetical error. Well, it happens. I just want to be careful about that. All right, so 200 to, yeah, 200, 360. Okay, there you go. 192. Now for the measure of angle D. Okay, well, using the rule from before, the measure of angle D is equal to 1/2 the difference of the big arc. Here, our big arc caught in this angle here would be arc EFC, and the minor arc would be arc BC. And so here, again, same idea from before, that the measured angle formed by a tangent line and a secant line is equal to same as the same circle. Outside of the circle is 1/2 the measure of differences of the arc intercepted. So here, if we had this same idea that secant line PAB and tangent line PCD, the measure of angle P is equal to arc BC minus arc AC divided by 2. And we're going to go back to our question, but this is very much the same way, 1/2 the difference of the intercepted arcs. And so we're going to do 1/2 of measure of arc EFC minus the measure of arc BC, which will be 1/2 of 192 minus 72. Well, that's 1/2 of, I believe that's going to be 1/2 of 120 is equal to 60 degrees. So the measure of angle D equals 60 degrees. Okay, ladies and gentlemen, so we now talked about a new concept. So the concept of when two secants intersect a circle and the measure of the angle from the point external to the circle, as well as when the angle formed by a tangent and a secant, whose vertex is a point outside the circle. So basically the same concept, 1/2 the difference of the two intercepted arcs. Ladies and gentlemen, I hope you found this helpful. Please leave a like and subscribe to our channel, turn on notifications. And of course, thank you for watching again. Watch out for part 3. Take care and be safe.